Hi everyone, my name is Vinayak Hegde, and today we are going to talk about building a tech stack. So a little bit about me. I'm the CTO in residence at Microsoft for Startups, and I help startups in a program with making good technology choices, building a good tech stack, scaling a tech stack, a little bit help with product strategy, and getting the right team in place to execute that strategy. Microsoft for Startups is on a mission to help all founders innovate and grow, no matter their background, location, or progress. So any founder can apply to the startup program regardless of any constraints. So it's really open for everyone. And I highly encourage you to apply. We will have the links at the end, and we give a whole range of benefits for startups. Whether it's first party, we give access to Azure credits all the way from 1K to 150K. We give access to LinkedIn benefits, GitHub benefits. We also have access to third party benefits such as OpenAI, Data, or Bubble.io. Also, you would get access to experts like me and others who would help you build your application on top of Azure and actually scale up your application to help your customers. So with that, I will move on to the next slide where I'll talk about a little bit about what is the flow of the talk flow. So here I'm going to give a little bit idea of what the talk would do. It would be like a what would the typical tech stack look like? What kind of architectural styles make sense, especially for early stage startups? What are the different components, and what are the typical design choice considerations for those so that you can choose a good stack? So let me go on to the next slide to go about this in a little bit more detail. A typical tech stack. So this is how a typical tech stack would look. You have users on one side, and the users would use the devices or use the browser or use a mobile app. And then that request would go over the internet to the load balancer, which would intercept based on where the user is. And then that request would then go to the application servers. The application servers would have like maybe custom logic, that processes the data. Possibly it can also request data from the database or the caches. And once it has got all of the data, it has applied the business logic, then it can take that data and then return it back via the load balancer to the user. So the users in this case need not necessarily be humans. They can be machines as well. A good example is data for an agri-tech startup. Maybe you have sensors in the ground or in the farm, and they send sensor data back to the server, and then maybe you have an alerting system or like an aggregation system or a dashboard that gets driven out of this data. Possibly there is some amount of machine learning AI or alerting system that sends any configuration data back to the IoT systems. Yeah. So I just wanted to point it out that users need not necessarily be human; they could be machines as well. So the typical debate is a monolith. Would you use a monolith or would you use a microservices? And typically what we have found is a monolith makes sense for early stage startups, and as you grow, I think maybe microservices make sense, and I'll talk a little bit more about that in the next slide. Monolith versus microservices. So let me cover the scenarios where the monolith makes sense. A monolith is easier to debug initially and deploy. It's easier to debug and change fast. All the context is in the head of a small generalist team, because that is the early team that builds the app. Because the team is small, there's lower communication overhead, both in terms of the team and also in terms of the app. And typically, when you deploy a monolith app, there are hardly any DevOps skills initially in organization. I mean, this is not true of every startup, but most startups that I have worked with have this. And there is lots of code changes and code churn, that can be done using a monolith. Monolith versus microservices, and monolith also has downsides. As you grow, making changes is harder. Build and deploy takes time. That becomes the gating factor for deploying anything to production. Because it's one code base, it might, as the team grows, it might be hard for one person or a small team to understand the entire code base. And as you grow, you might want to introduce new technology, right? So it becomes harder to introduce new technology because everything is talking to everything else, and it's just one huge code base. Scalability is very coarse, so you might run multiple instances of the monolith, or the other option is you have to vertically scale. So let's look at option. So there are multiple advantages of microservices. I would say the best advantage is responsibility principle. A microservices does one thing and does one thing well. It can be autonomous with well-defined interfaces. There can be technical heterogeneity. What that means is if you have multiple languages in your stack, you can build in the best language for that problem domain. It's also resilient. You fail with proper errors or debugging, and cascading failures are much less, because in the case of just to contrast it with a monolith, if the monolith fails, then the entire application goes down. Other advantages of microservices, because each microservice is independent, it can be scaled independently. Each of it has its own feedback system. It becomes easier to deploy because if you have 10 microservices, you can individually deploy each of them. Like the authentication system can be different from, say, the metadata service, can be different from maybe, say, the logging service. And that makes life easy for you as a development team. And because that leads to organizational alignment as well. So you have small focus team that are scaling for growth. There's improved autonomy. And also each of these small teams can specialize in that particular microservice, right? So that not only does the application scale, but also the team grows. And as I said earlier also, because the entire monolith is divided into different parts, you are optimizing for replaceability and upgrades, right? And while you're doing all of this, your pace of delivering software becomes faster. So you're reducing time to market all the time while reducing risk as well, which is in some sense the holy grail. Once you have thought about the application itself, the next part that we look at is like choosing the right database. And this is important because the choice of database can dictate, how fast or slow or how scalable your application is. So there are a few parameters that you would use to choose a good database or data store, and I'll go a little bit more in detail in the next slide. So does it get the basics right? Is it possible to query data easily? Is it possible to store data easily? Is it possible to dump that data easily? Is it possible to take backups easily? So these are some of the things that you need to think about. And most databases get these parts right, but we have had instances, I've seen instances where databases can lose data, right? So you have to be a little careful about that. Also, you need to be sure about what are your specific needs. Like, for example, do you use a GIS or a geographic information system? Are you storing individual documents? Are you using key value kind of setup, or are you using a time series, right? And each of these can add a different dimension to the way you store data. The other things that you need to be aware of, and this is again an extension of the basics, is what kind of data types you support. How is the indexing? How, I would say, expressive is the querying? How does it actually store data? Is the data storage requirement very large, or does it compress data? Does it store in a columnar format? Does it store in a row format? Those are the things you would look out to. And also look at the surrounding ecosystem, right? Because no software is used in isolation. So look at the tooling, the extensions, the open source support. And last but not the least, how easy is it to operate and run? Here I go a little bit deeper into different kinds of databases. So typically, I would say there are two or three types. I would say OLTP, or online transactional processing, OLAP, or online analytical processing, and the third category, which is relatively newer, is schemaless, right? So if you see the chart, each of them have different data models. Each of them have different granularity. Again, the update size is different. Typically in OLTP, you have immediate consistency. OLAP has eventual, and schemaless also is typically eventual, right? Another important difference between these three is OLTP is typically row oriented. OLAP is typically column oriented, and schema actually is either key based, and then using the key, the retrieval of the document is there. Some of them allow retrieval of document through secondary indexes as well. So what are the use cases of these? OLTP actually is a good example is e-commerce. So whenever you send out an order, or you order something on any kind of online store, the order will be stored in a typically a row-based database, or online transactional processing database. But like if you want to, if a customer, or if the online store wants to know what is the average basket size, how often are you ordering, and what is the average size of basket that you have, or in terms of monetary value, they can run analytically. So basically, what you would do is aggregate all of your purchases, and then kind of slice and dice it by time and other things. So these are typically analytical queries where there is some kind of aggregation involved. And finally, there's schemaless, where you typically might store, like for example, a user's address, their attributes, maybe what are likes, dislikes, any recommendations, maybe any kind of categorization that you have used using AI/ML, and it can be kind of free form, right? So typically, it would be schemaless. And I've given examples for each of these. For OLTP, I would say Postgres is good. For OLAP, something like ClickHouse or CitusDB is good. And for schemaless, I would say MongoDB or Couchbase are good choices. Last part, we'll talk about choosing the right language or framework. And let's go a little bit deeper into that. Right. So choosing a good language or framework. Slide 14, choosing a good language or framework. Depends on a bunch of things. What is the kind of application you're building? Are you building maybe something like a messaging app which has a lot of messages going through? Are you building an IoT app which kind of is deployed in the field? Are you building a web app which has interfaces both in the mobile phone and also on the computer? So the type of application can dictate the language choice, right? For example, if you're building a web app, JavaScript is a good language to start with. If you're building something in the backend that needs higher level of consistency and checking, then maybe you'd probably use something like Go or Rust or Java, right? And when you choose a language, you don't choose a software or language in isolation, right? You look at the tooling, what is the integrated development environment support or IDE support, what are the different testing frameworks that are available, what are the libraries, and how is the open source support for each. And I think most importantly for startups, what is the talent availability, for that particular language or framework that's available. And as you scale, is the language scalable? Can it serve hundreds of thousands of requests? Is it possible to debug very easily? Is it easy to maintain? So these are some of the questions that would come up. And when I look at languages or framework, I typically advise startups to look at two different aspects. Choose a statically typed language, especially for the backend. And popular choices for that are like Go, Rust, or Java. And on the front end or the web apps or something that you want to quickly iterate through, and you're kind of discovering what is a typical use, you would use something like Ruby, Python, or JavaScript, right? So these are, I would say, the rules of thumb that I would typically say when you're choosing any kind of applications. And if you keep this in mind, I think you can build a fairly robust stack. Obviously, as engineers, there are nuances to this, but these are like good rules of thumbs to build a robust and scalable tech stack. Thank you everyone for going through this presentation. And if you want to learn more and you have access to other learning resources at Microsoft Learn, and links are on the screen, so you can click through to the links and learn more about what are the good choices when it comes to a tech stack. There are also learn modules specifically for developers or for building a startup as well. And to get access to our program, you can sign up on the Founders Hub link, which is mentioned, and you can get access to all of the different benefits, whether it's technical, business, or the different tools that we have. And I would look forward to working with you once you sign up. Thank you so much.